Hi, and welcome to Module 17 of Lecture 1. This module is a problem session to finish out Lecture 1. We're going to go over a few practice problems. The goal here is I will put up the problem first. You should then pause the video ideally, try to work through it yourself, and then follow through with my own reasoning and math or whatever after you've tried it yourself. Besides this problem session, as a way to practice, there's also a brief problem set with solutions available online that you can see as well to use as additional practice. Okay, so just a few problems for this first lecture. The first one, we're going to start off with a list of numbers taken from some sample. So the numbers will be 5, 2, 4, 9, 2, 7, 3, 4, 2, and 2. So a bunch of one-digit numbers. There are 10 of them here. And so the question is going to be, calculate the mode, the median, the mean, and the sample variance, and find the sample standard deviation. That's an I. Okay, so it's a good time to pause, try to work through this yourself, and then come back again when you've solved them. It's always awkward to do that. Okay, so now, hopefully you've done these yourself, so this should be pretty clear now that you work through them. But anyway, so for the mode is the most common value here. And we see there are 4 2's, there are also 2 4's, and nothing else repeated. So 2 is going to be the mode of this sample data set. Now for the median, the way to do the median is you're going to want to order them. So let's put them in order. 2, 2, 2, 2, then 3, then 4, and 4, and 5, and 7, and 9. So the median is the middle number or numbers. Now there are 10 of these, so it's an even number, so we can't choose the middle one, we have to choose the average of the middle 2. So here are the first 5, 4 2's and a 3. And the last 5 are from here on. So these 2 over here are the middle. So the middle is the average of the central 2 numbers, which is 3.5. Had we had no 9 here, the median would have been 3. Had we had no 2 here, the median would have been 4. Okay, so that's the median. And the mean is the average. To get the average, we take the sum of all of our data points and divide by the number of data points. Here we have 1 over 10 times 2 plus 2 plus 2 plus 2, it's 8, plus 3 is 11, plus 4 is 15, plus 4 is 19, plus 5 is 24, plus 7 is 31, plus 9 is 40. So it's 1/10 times 40, and that's going to equal 4. So the mean is 4. Now for the variance, we're going to do, and I'll put these together so we can have more room, is to compute, and this is a sample variance, so it's 1 over n minus 1. We're going to compute the sum of all the deviations. So xi minus the mean, which is x bar, squared. So the sum of all the sample deviations squared. Okay, the sum of squared errors. And I'll write over here to make clear this is the mean right here. Okay, so what's this? We have 4 2's, so 4 times whatever that deviation is. 2 minus 4 is negative 2, and we square that. So we have 4 times negative 2 squared. Then we add our 3. 3 minus 4 is negative 1, so that's negative 1 squared. Then we have 4 minus 4 twice. 4 minus 4 is 0, so we're going to square the 0, that's going to go away. Then we have 5 minus 4, which is 1 squared. Then we have 7 minus 4, which is 3 squared. And then finally we have 9 minus 4, which is 5 squared. So over here we have 4 times 4 is 16. So this equals 4 times 4, because negative 2 squared is 4. So it's 16 plus 1 plus 0 plus 1 plus 9 plus 25. So this 16 plus 9 is 25. 25 plus 25 is 50. Plus 2 is 52. So it's 52. And this was all just a sum. So now we have 52 divided by n minus 1 is 9, which is 5 and 7/9, or about 5.78 or so, approximately. To get the sample standard deviation, and this thing, by the way, is s squared. So to get the sample standard deviation, s equals the square root of s squared, which is approximately 2.4. That's it. If this had been the whole population, not a sample, we would have divided by n instead of n minus 1 and gotten 52 over 10, which is 5.2. So it would have been slightly lower standard deviation for variance and standard deviation for the population as opposed to a sample. Okay. So that's this. That's most of what I want to do. I want to try one more thing, just a small proof. We earlier said that the mean had this property, that the sum of all its deviations equals 0. So we can work through that pretty quickly and show why that's true. So how do we do with the sum? Well, the sum of any numbers a minus b is just the sum of a minus the sum of b. That's generally true. So what do we do with that? Well, this thing then becomes the sum of xi minus the sum of x bar. Well, what's that? So the sum of xi, remember the mean definition from up here is x bar equals 1 over n times the sum of xi. So if I multiply both sides by n, I get the sum of xi equals n times the mean. So the first term here is going to equal n times the mean. What about the second term? Well, the second term is the sum of x bar. Now, x bar is a constant. It's the same for every I, so we can pull it out of the sum, and we get the sum of 1 from I equals 1 to n. So basically, I'm adding 1 n times, which is n times 1, or n. So the first term is n x bar, and the second term is x bar times n. But those are the same, so we have 0. And that's why that property we talked about earlier, that the sum of all deviations is always 0, and it's always 0 due to this definition of what the mean is. Okay, the nice thing about this stuff is you can make up your own problems really easily. Pick any series of numbers, you can calculate the mode, the mean, the median, and the variance, and that can be useful for getting a handle on this stuff and getting yourself more comfortable with these calculations. Again, there's a couple more problems on the problem set. Most of the problem set is about thinking through a research question. There's not one answer to that. There could be many answers, but it will help you think about how to go about thinking about research questions. Sort of a little meta there. And then at the end, there's a problem that looks like the first problem here, so you can get more practice. But again, you can do this yourself. You can make up your own numbers pretty quickly and calculate your own stuff. And that's it for lecture 1. Lecture 2, we'll be starting with inference. Thank you very much.